Today I'm gonna take a closer look at my code for my vector calculator application. This application helps you to do different vector operations like calculating dot products, cross products, divergence, curl, gradient. It also shows a visualization in 3D of divergence, curl, gradient. We will go through each function step by step. So let's begin. Let's talk about what vectors are. Vectors are quantities that have both direction and magnitude. You can think of them as arrows pointing from one point to another in a space. In our application, we can see the interface where we can enter the components of two vectors v1 and v2. For example, we will use v1 is equal to 1, 1, 0 and v2 is equal to 1, 0, 1. Let's calculate the dot product. When we press the dot product button, it will see the answer. This means the vector have some similarity in direction. Next, we have the cross product. This operation takes two vectors and gives us another vector that is perpendicular to both of them. This is really useful in many applications, especially in physics and engineering. For vector 1 and vector 2, the cross product gives us the vector 1, minus 1, minus 1. This is a new vector that is perpendicular to both of the original vectors. In our graph, the green line represents the cross product that is perpendicular to both of the original vectors. This feature uses the dot product and the magnitude of the vector to calculate the angle in degrees. When we calculate the angle between vector 1 and vector 2, we get approximately 60 degrees, which is useful information in many applications. Let's calculate the resultant vector. This is simply the sum of two vectors and gives us a new vector that represents the combined effect of both. The resultant vector of vector 1 and vector 2 is 2, 1, 1. This vector points in the direction that combines the both vector 1 and vector 2. Finally, let's explore the projection. The projection of one vector onto another tells us how much of one vector lies in the direction of the other vector. If we calculate the projection of vector 1 onto vector 2, we will find the projection. This indicates how much of vector 1 in the direction of vector 2.
It's not a game, it's a rich thing.
Let's start by looking at our class definition and the Divergence method. Here we define the vector calculator app class. The Divergence method initializes the main application window. We set the title and dimension of the window and also establish the minimum size to ensure the usability. The method self-create widget is also here, which we will explore next. This approach keeps our code organized as it separates the initialization logic from the user interface setup. Let's talk about Divergence. Divergence is the short form for double underscore, which refers to the two underscore before and after init. We then create various widgets to gather user input and display results. We start by creating a header frame that contains a label for the application title. Then we proceed to create a dedicated frame for vector input. This part of the interface is crucial as it allows users to enter the vectors they wish to calculate. We prompt the user to input two vectors in the format of x, y, z, where x, y, z are the respective coordinates in three-dimensional space. By using entry fields, we provide a straightforward way for users to input their data. This design enhances the usability, making the application accessible even to those who may not be familiar with vector operations. Following the input fields, we add buttons for each calculation we want to perform: the dot product, cross product, curl, and divergence. Each button is linked to a specific method that performs the corresponding calculation when clicked. This interactive design allows users to initiate the calculation with a simple click, making the application user-friendly. We also include a level specifically designed to display the result for our calculation. By initializing this level with an empty string, we ensure that it can be dynamically adjusted and updated to show the output of whatever calculation is performed. The choice of a larger font enhances the readability, allowing users to quickly grasp the result of their vector operation without straining their eyes. In this method, we use list comprehension to convert the string input from the user into NumPy arrays. We split the input string by commas and convert each component into a float. If the input format is incorrect, a message box displays an error, guiding user to enter the vector value in the correct format. This is a key function because accurate vector input is essential